Hello everyone, welcome to my chemistry channel B.L.Dash short and sweet in chemistry. Now I am going to explain that one analysis of group cations. I already told there are 6 groups including 0 group, and here in 5th group I have already explained 0 first group and second group. In part 6a I am going to explain group 3 cations and group 4 cations. Here we will see group 3 cations. Generally, group 3 cations Fe+3 and Al+3 are very important. Now you can see first how you know that Fe+3, Al+3, that is group 3rd present. So you will here add 5 drops of concentrated nitric acid to the salt solution. Question is why? Actually, if any salt, if any ions Fe+2 present, then it will oxidize to Fe+3. To that, we will add ammonium chloride, that is should be solid, and ammonium hydroxide. Then what happened here? Here we will see what is the result. Precipitate is formed. Then what is the color of the precipitate? Because there are 2 ions present, Fe+3 and Al+3. So what is the color of the precipitate? If it is reddish color, reddish brownish color, then it is Fe+3. If it is white gelatinous precipitate, then it is maybe Al+3. That again you see, first you will add concentrated nitric acid 5 drops because you want to oxidize Fe+2, Fe+3. Then if any precipitate obtained, now here if precipitate obtained, you should observe what is the color of the precipitate. In reddish brown it may be Fe+3, and white gelatinous it is Al+3. Then we will go to confirm test for Fe+3. Now you are getting reddish brown precipitate, then it may be Fe+3. Then you take that reddish brown precipitate and add dilute hydrochloric acid. Then divide this solution into 2 parts. That means that reddish brown precipitate dissolve in our hydrochloric acid. Now here you should write, then here the precipitate dissolve in dilute hydrochloric acid. So you should write precipitate is dissolved in dilute HCl. Then you should observe what is the color. This is dissolved. That means here the to one part, it divided into 2 parts. To one part add what is the solution? Potassium ferrocyanide. Don't be confused. Potassium ferrocyanide and another one potassium sulfocyanide. First you are potassium ferrocyanide. Then what is the observation? You can find here the color is that is blue color. Then what is the color? Blue color. It's very important. And here you will observe blue color if you add potassium ferrocyanide, then it is blue color. And if you add the next one, see, one is potassium ferrocyanide and other one is potassium sulfocyanide. To other part solution added potassium ferrocyanide solution, then what is the color? Blood red color. Remember, in the 2 solution, one is sulfur, other one is ferro, and there is a difference of the color. If potassium ferrocyanide, that is blue color, that is confirmed Fe+3, and if it is potassium sulfocyanide, then blood red color. So very important, how can you confirm Fe+3 by 2 solution? One is that is potassium ferrocyanide and other one is potassium sulfocyanide. Then sulfocyanide gives blood red color. Then confirm, you will go to confirm test for Al+3. I hope it is clear how can you confirm the Fe+3 by two tests. One is potassium, that is ferrocyanide, other one is potassium sulfocyanide. Then confirm test for Al+3. Then what is difference here? And you can observe Al+3, if it is, then what type of precipitate you are getting? White gelatinous precipitate. So here also you will add dilute hydrochloric acid to the white gelatinous precipitate. Then what happened? White precipitate dissolve. And in Fe+3 what you are getting? That is brown precipitate. And here what you are getting? This is white precipitate. Then what happened here? Maybe aluminium +3, Al+3, and here dissolve the precipitate. Dissolve the white precipitate is obtained. Then first is, if you are adding dilute hydrochloric acid to the white gelatinous precipitate, and here you will get white precipitate dissolve. Then dissolve the precipitate and added blue litmus solution. After dissolve, you will add blue litmus solution. One solution it is available in laboratory, chemistry laboratory. You immediately add blue litmus solution. This is very important, and that is called blue litmus solution. Then after you will check here. What is that? Dissolve the that is blue color develop with blue precipitate floating. That means it is not a simple solution. Here blue color solution is there, and in the middle part, in that solution, you can find blue precipitate floating. You can imagine, then if it is blue color solution and blue precipitate floating, it should be confirm Al+3. Again you see, first what white gelatinous precipitate is there, to that dilute HCl is added. Then what happened? Precipitate dissolve, and it may be Al+3. To the dissolved precipitate you add litmus solution. What is that? There are two types of litmus solution. One is blue litmus, other one is, and here you will add blue litmus solution. Then here you can go and it is sure that confirm Al+3. Then what are the possible reaction? When you are adding ammonium chloride and ammonium hydroxide, then what happen here? Ferric chloride, it gives reddish brown color. If reddish brown color, that is called ferric hydroxide, and here it is very very important, this is reddish brown color, then you can imagine it may be, this is the reaction. Now if AlCl3 aluminum chloride, if ammonium hydroxide ammonium chloride are added, excess of ammonium chloride, and that you can find white precipitate, that is aluminum hydroxide, that is a gelatinous precipitate. Ferric, then if you want to dissolve, then it comes to solution. You remember here I have added dilute hydrochloric acid, then it becomes solution. Potassium ferrocyanide, this is called blue color. You remember potassium ferrocyanide, and it gives ferric ferrocyanide. Remember, this is very important for the different type entrance exam, different type of other examination. You can find what is the formula of ferric ferrocyanide, what is the color. Similarly, when you are adding potassium sulfocyanide, then it is ferric sulfocyanide, that is blood red color. Similarly, lactase, that means here blue precipitate floating on blue solution. Aluminum hydroxide, that is white gelatinous precipitate, dissolve in hydrochloric acid, it gives that is AlCl3 aqueous. Then here if you are ammonium hydroxide, then it gives what is that one? Blue precipitate, and here over blue solution. Then come to fourth group cation. Now third group completed. There are how many cations? One is Fe+3, another is Al+3. From the first step you should know the color, and after that individual confirm test you will do. Then here it is confirm either Fe+3 then or Al+3. First you do Fe+3, then you do Al+3. Then come to group 4 cations. Group 4 cations generally what are present? That is cobalt, nickel, manganese and zinc. All are containing +2 ions. Then here what happened? You take what is the first experiment, how to know whether 4 group cations present or not. That is CO +2, Ni +2, Mn +2, Zn +2 by its color of the precipitator. That means here you will take ammonium chloride and ammonium hydroxide saturated solution and add it to the salt solution. Remember, you should add to the salt solution because it is known as wet test. Then pass H2S gas, you will pass H2S gas. Then color precipitate, different color, different ions give different colors. So color precipitate is formed maybe 4th group cations. Out of 4, one may be present, and you should know what is the color of all the precipitate after adding NH4Cl, NH4OH and passing H2S gas. Now black precipitate, then CO +2 and Ni +2. If black, then you are sure that it may be CO +2 or maybe Ni +2. If buff color precipitate, buff color, that means it is light, very light white color, grey color like this, a very light color, and this is called Mn +2. Mn +2, if it is buff color, and if it is dirty white color, see these two are different. One buff color, that is more than dirty white color, more blackish color or greyish color than zinc. Zinc dirty white color. Then out of 4, if one salt containing these ions, one of these any ion, then you can sure that by this first test you are sure that one may be by its color and by its precipitate. Generally by its color you should know what cations may be. And after that, you will do confirm test one by one. First, you do cobalt, CO +2. Dissolve the black precipitate in aqua regia. Aqua regia, what is the aqua regia? 1 part HNO3, 3 part HCl, and it is aqua regia. And here, what you will do? Here, aqua regia and evaporate to dryness. Then here aqua regia you will add this black precipitate. Then after dissolving, evaporate this solution in dryness in a china dish. You know china dish, white color porcelain. And here in a china dish you heat it, blue residue form. Lastly, what is present? Blue residue. Then only you can show, yes, confirm CO +2. That means you dissolve the black precipitate in aqua regia. Then heat it. And dissolve the residue in water. What residue? Blue residue in water. Then what happened? Pink color solution is formed. Remember, it is a blue residue and dissolve in water, it gives confirm then CO +2 if you are getting pink color. Divide this solution in 2 parts. What you are getting the knowledge? Blue residue, then dissolve in water, then it is pink color, it is confirm CO +2. Again the solution divided into 2 parts. After that you see to 1 part, what you will add? Ammonium hydroxide and acetic acid with few crystal of KNO2. You should remember, first you will add ammonium hydroxide, acetic acid, then you will add potassium nitrite. If KNO3 nitrate, it is NO2, that is why potassium nitrite. Then yellow precipitate is a form when you are adding ammonium hydroxide, acetic acid, KNO3 crystal mean that is solid one, that is in the crystal form. Then what happened? Yellow precipitate is formed. It is also CO +2 confirm. To the second part, ether, crystal of ammonium thiocyanate, shake properly, allowed to stand. That means what you will do? First you take a second part solution, then add ether, crystal of ammonium thiocyanate, then it gives blue color in ethereal layer. That means you can observe there are 2 parts, one is water layer, another is ether layer. Here blue color in ether layer form. That is very, very important. How can you get the ether, blue color ether layer? Then confirm test of what? Nickel plus 2. That means cobalt is finished. Then come to nickel. Dissolve the black precipitate. Here you remember in cobalt plus 2 also, CO plus 2 also, you are dissolving the black precipitate in aqua regia, and here also you will aqua regia and evaporate in a china dish, yellow residue is formed. Then here Ni plus 2 conform. And dissolve the yellow precipitate in water. That yellow precipitate you should dissolve. Then what happened? Green color solution is formed. Very important. Green color solution is obtained. Then Ni plus 2 conform. Again this green solution divided into two parts. Remember, dissolve this yellow precipitate. Dissolve the yellow precipitate in water. Then you will divide into two parts. The green color solution to one. First part you will add ammonium chloride solution and added with few drops of dimethyl glycine. You remember nickel is 1, Ni plus 2 is 1, only very, very important reaction, that is with dimethyl glycine. Then bright rose red precipitate, bright rose red. The rose red, you know, the looks like rose red and bright shining color and precipitate obtained. Then it is Ni plus 2 conform. Then for Ni plus 2, what happened? Aqua regia dissolve, yellow residue form, dissolve in water, green color solution obtained, that is divided in two parts. To one part, you will add ammonium hydroxide with few drops of dimethyl glycine, and here to the second part, simply ammonium hydroxide and bromine water, black precipitate is formed. It is also very important. If you add ammonium hydroxide and bromine water, black precipitate form. Then it is conform. Ni plus 2 conform. Then come to manganese. But you know, when ammonium chloride, ammonium hydroxide is added to salt solution, if it is buff color precipitate is formed, then it may be Mn plus 2. And how to do the conform test? So the precipitate dissolve in added dilute HCl and NO is added and shake it. Then white precipitate form. Remember that buff color precipitate dissolve in dilute HCl, then NaOH is added, white precipitate is formed. Then do this white precipitate, bromine water is added. It turn to brown color. Remember, first it will give a bromine water is added to white precipitate. This here you are getting white precipitate after adding NaOH. Then it turns to brown color. Then it conform Mn plus 2. Again, take the black precipitate and add concentrated nitric acid. Then here it is lead peroxide you will add, boil properly, cool and allow stand. You remember here what you will do? Black precipitate, first add concentrated nitric acid. Then add lead peroxide, boiled, cool, then stand. And pink color solution is formed, and here this pink color from solution you can remember this is Mn plus 2. Then come to borax bead test. Blue bead form CO plus 2, brown bead form Ni plus 2, pink bead form then Mn plus 2. We also know in borax bead test, this is the important borax bead test color. Then you will do conform test for zinc. See here, you know when you add ammonium chloride, ammonium hydroxide and passed H2S gas, dull white. If it is dull white color, then it is zinc plus 2 maybe. Then add dilute hydrochloric acid. Then divide in two parts. To part 1, what you will do? You observe. To part 1, simply Na solution added. Again see, dull white precipitate is formed, where you will add, what you will add? You divide in two parts, and to part 1 add NaO solution. White precipitate is formed. But if you add more more NOH, then white precipitate dissolve. Then it may be, zinc plus 2 conform. Then here zinc plus 2 conform. Are you clear? Dull white precipitate is dissolved in dilute HCl, divided into two parts. Two part one simply NOH solution added drop wise, because from in the beginning you will get white precipitate, and more NOH added, it is dissolved. Then second part added potassium ferrocyanide. Potassium ferrocyanide, it gives white or bluish white precipitate or little white bluish color precipitate. Generally bluish white precipitate is obtained and Zn plus 2 conform. Then cobalt nitrate test. You remember in dry test you have done cobalt nitrate test. In cobalt nitrate test greenish residue form, that is zinc conform. You have done in earlier. Then chemical reaction of cobalt, nickel, zinc and manganese. Then here cobalt hydroxide H2S gas pass, then it gives cobalt sulfide black color, nickel sulfide black color, zinc sulfide buff color. And one is left, I think, manganese is dirty white color. Then you say test for cobalt plus 2. First you take potassium nitrate crystal. Remember, you are adding potassium nitrate crystal. It gives cobaltous nitrite, where in the presence of acetic acid, it gives nitrous acid. And here, cobalt nitrate, this HNO2, what you are getting HNO2 here? This HNO, what is HNO2? Nitrous acid. What is the nitric acid? HNO3. This is called cobaltic nitrate. This cobaltic nitrate, now what is cobalt nitride? Sodium, potassium nitride is left. Here it will react with cobaltic nitride. Then you can see it is a large, big reaction having 1, 2, 3, 4 steps. Lastly, you are getting yellow precipitate, that is potassium cobaltic nitrite. So with the help of potassium nitrite, acetic acid, lastly you are getting yellow precipitate. Ammonium thiocyanate, that is giving yellow color. This complex you may remember or not, that depends on you, but the color you should remember. Then test for Ni, this is called dimethylglyoxime. Many times what is the formula structure of dimethylglyoxime is asked, so you should remember what is the color of what is the structure of dimethylglyoxime. It will give what they call one, bright red rose color, bright rose red color precipitate is formed, and this is also very complex structure, you may remember or not. Sodium hydroxide and bromine water test. See, sodium hydroxide first you are adding sodium hydroxide, green precipitate obtained, bromine water added, then lastly you get black precipitate. Very important reaction. Then test for manganese, NaOH with bromine water, lastly you get white precipitate. Then here bromine water, lastly it gives with help of hydrolysis with water and bromine, it gives that one called black precipitate, MnO with OH whole 2. Then here it gives a black precipitate. Remember what is the color here. Then lead oxide test. Here also you will take pink solution. Lastly you will get pink solution by the help of manganese. Here manganese, that is HMNO4, for manganate, KMNO4, manganic acid, HMNO4, that is pink solution. Then test for zinc. Here you will add dilute HCl, it will dissolve because it is ZnCl2, and after that the ZnCl2 NOH is adding white precipitate often. If excess of white precipitate dissolve, that is sodium zincate. What is this one? Sodium zincate. This is called sodium zincate. Potassium ferrocyanide, which gives white or blue precipitate. That's very, very important, where you should remember what is the here Zn2 FeCN6. Okay, this is a complex compound, coordination compound, and here potassium ferrocyanide. Here potassium ferrocyanide, that is also complex compound, and that is coordination compound by which you are getting white or blue color precipitate. So I hope it is clear. In third group, in third group and fourth group, what are the cations present, you can observe here. Again, see if any doubt here. See, first is sorry, here test for aluminium. Then group 4 cations where cobalt plus 2, Ni plus 2, Mn plus 2, Zn plus 2. From the beginning you should read, you should remember what test one by one, so that qualitative analysis for basic radical, if a fourth group cations anyone is present, you can do with success. Similarly, third group also aluminium, Al plus 3, Fe plus 3 are present. If anyone cation is present in your salt, then surely you will get by the confirmed test what is the radical. Thanks for watching my video, and thanks again to all.